So yeah, that's me. I've been doing this for a while. Sort of my first sort of, well, actually I started using Python before I started using Zope, but Zope came very shortly after. For a little while, Zope was almost as popular as Python itself, and it's sort of the granddaddy of Python web frameworks. And I've done sort of various things over the years. And the last few years, the Python thing I've been doing is Morepath, which is yet another web framework. So I submitted this talk to BikeRun, and the talk instruction said, keep it technical, aim for a maximum information density, and sometimes code speaks louder than words. It's like, okay, sure, I can do that. Right? I'll just give everybody, it's just a normal talk, it's not a keynote, I'll give everybody a Morepath implementation detail overload, right? I've seen guys done talks like that, and your brain start to melt like halfway, but they can still be a lot of fun. But then I got a sudden keynote upgrade. That's how sometimes these community-run conferences work. Keynotes, they have to be inspirational, they shouldn't have any real content, they should have no code samples, no meta classes, and no brains from ears, right? So I had another keynote upgrade when I first announced Morepath in 2013. My talk also got upgraded to keynote. So okay, I'll need keynote, need inspiration in there, and I'll just cram in technical stuff as well. And then the talk had a lot of content overload. It ran too long and all that stuff. So, you know, I learned my lesson, and okay, I haven't learned my lessons, so hold on to your brains. There we go. So what's this talk about? It's about implementation details of Morepath and sort of the history behind that. It's also about concepts in Python web frameworks or web frameworks in general and the history thereof. And it's about creativity in software development, like where do these ideas come from? So Morepath is this micro framework, it's a web framework, and it claims to have superpowers. So if you have superpowers, you need to come from an exploding planet. In this case, it's the exploding planet Zope, and Morepath is the last web framework that made it out of there. It's not the last sort of web framework that came out of there. Pyramid also came out of this a few years earlier when Krypton wasn't quite exploding yet, perhaps. So Morepath claims to have superpowers. So what are these superpowers? Well, it has a unique approach to routing, which I'll talk a lot about, and also to link generation. I believe that web frameworks should be able to generate links for you, because resolving a URL to a web page is one thing, but also just generating a link to a web page. It's a web framework should be doing this. And I call this sort of this part of Morepath Traject. What Morepath also has, it allows you to write generic code very easily. You can write code that applies to whole classes of things or any subclasses of particular things. You can do the sort of generic views, things like that. And when you write code in Morepath, it should be easy to have an application, and then you want to deploy it in a different context. You don't want to change the original application. You want to be able to extend the original application and override it. And the component that does that is called Dectate. So let's talk about Traject first. So in the early 90s, there was this thing called file system traversal. It's still around. So when you have a URL, example.com, and then you have some path addresses /Faassen, my address, then somewhere in the web server configuration you say, okay, you go to this particular root directory, and then you look for a subdirectory called addresses, and then you look for a file called Faassen, and then that file just contains HTML, and the web server should just deliver that. That's file system traversal. It's a very venerable way of publishing things to the web, and it still works fine. So what Zope 2 came up with, and its predecessor Bobo in the sort of late 90s, is this concept of traversal still, but not through the file system, but through an object tree. So you have your root object somewhere, and in the root object there are other Python objects, and you just traverse through. When you get a path like addresses Faassen, you transform that to root.addresses.Faassen, or perhaps a get item away, or a combination thereof. And then in the end, when you get this object, you want to be able to display it, and generally you would just call a method if that method had the same last name as was in the path, so it had the same name as the last segment in the path. But if there was no such method, it would just call index under HTML, and that would just be a function that just delivers HTML. So how would you implement that when you're a developer? You would have some kind of address container, which needs to be in a root. I haven't just showed that bit. And then you implement some getItem method. You say, OK, if I ever get a name like Faassen, then I will do some database query for that name. And if then you return an instance of address there, and that has a method, and the method shows you a bit of HTML, like the street in the address. And the drawback of this is that all the objects that you want to display on the web, I mean, the benefit is all just Python. You don't need to configure anything. The drawback is that all the objects need to have code to support web stuff, so they don't just talk about their own business logic anymore. They also need to talk about web stuff. So that was a bit annoying. But anyway, the creativity behind this object traversal is to take an existing concept like file system traversal and then apply it in a new context. What if we did this with Python objects? What would happen? That was sort of the creative notion behind ZOAP 2. And another example of sort of the same style of creativity is what you saw in the last few years with client-side JavaScript MVC frameworks, like Backbone or Angular or Ember. They took things like routing and templates and view model separation from server frameworks and apply them. What would happen if you do this on the client, if you do this in a web browser? Same creative principle. So then we had this annoying thing that content objects, they don't know about the web. Content objects have to know about the web, but we don't want our content objects to know about the web. We just want them to be plain database objects that have methods that deal with what they're really about, not also stuff about traversing and HTML generation. So the idea was, OK, we'll split off separate specialized components from that we sort of layer on these content objects that deal with traversal and HTML. And these components can be pretty clever. They can be aware of inheritance. So if I am traversing through an address and there's a subclass of address, that component will still apply to the subclass as well. So what does that look like? Well, then the system that handles paths looks like this. You have you start at a root object and you ask for the traversable component for it with an interface. And then once you have that component, you call the traverse method on it with the first segment of the path addresses. And you get your addresses object, which is the address container instance. And then you ask for the addresses. You ask for a traversable again from the addresses container, and you traverse to the individual address. And then in the end, when you actually want to display that address as HTML or whatever, might be JSON, but it didn't exist yet back then, is you say, OK, I have an address and I have a request. Now give me some object that can actually generate a view for it, and then just call that object. The object implements under call, and then it gives you back some HTML. So that's how ZOAP 3 worked. And then you actually do need to do more work as a developer to make this work, because you suddenly need to do quite a bit of registration. So for the address container, you need to say, OK, this is a component that takes an address container and makes a traversable out of it. It's called an adapter. And what happens then is that you take the object you want to adapt, the address container is the context here and in it, and then you implement a traverse method that does that query we had before. And the view looks very similar. It takes the context and the request, and then you have a call method, and that call method uses the context object, which is the address instance, to display some HTML. So that was ZOAP 3. And the nice thing about this is that suddenly the address object itself and the address container don't need to know anything about the web anymore. They can be web agnostic. So yeah, separation of concerns, that was sort of the driving force behind it, and the way that was solved is by doing indirection through some kind of lookup registry. Then you have Pyramid, which was sort of the other web framework that came out of ZOAP. They simplified it again. It was like, it's all getting a bit too complicated. Let's just do getItem-based traversal. And then view lookup, they actually made more complicated. They're saying, OK, the view depends not just on the class of that object that you have, but it might also depend on information in the request. And I'll talk more about that later. And then the developer writing Pyramid code will have to write an address container and implement a getItem that then does the query address. And you implement a view function that takes the context and the request and then delivers HTML again. But the drawback of this is that at least the objects you need to traverse through, not the objects you need to view, they need to be web aware again. You need to, there's this mixing of concerns going on again, which might not be an issue, but it might very well be. So what's the creativity here? Well, it's kind of a simplification. It's all just get item to traverse. And then this fancy predicate-based view lookup I'll talk more about later. So what you also have, and what's very common in modern web frameworks like Django and Flask, is routing, which is a very different way to actually resolve a path. So what you do then is you have some kind of map of routes that your system has, and then you give it a path, and then it will give you back a function, and it will give you back things it's extracted from the path, and then you call that function with the things you extracted from the path, and then that function gives you HTML. So this is how you do routing. What the developer needs to do, they say, okay, I have a route here that I need to register in this route map somehow in this registry. And I say, okay, for any route that comes in with a wildcard with a variable name, I write this view code, and the view does the query. It checks whether the query delivers something or not. If it's none, it needs to do a 404, and otherwise it can display the information you wanted. But now you need to handle this 404 manually. With traversal-based approaches, that's not a problem, because when traversal goes off into nowhere, you get none back or whatever, or you get a key error, it will just say 404, and the framework can do it for you. But now the developer needs to start doing this stuff. But yeah, it's all just kind of thing. It's all just calling functions in a route map. That's what resolving a path is like. So let's have a fight, right? So who wins here? Routing, traversal. Routing is declarative, it's succinct, it's routing doesn't require that the content objects need to be web aware. It's light on registration. There's not a lot of code here, right? I mean, it's pretty simple compared to the traversal approaches. Traversal gives you automatic 404s. It gives you these fancy reusable views that can be generic and all that stuff. And it lets you do link generation because you have a tree of what you traverse through. Generally, it's possible to reconstruct where you are when you say, okay, I have an address. Please give me the link to that address. And the system actually generates the link for you automatically based on this information. So, well, I don't want to fight, I want them all, basically. I want all these features. So Morepath has all these features. It routes first to a content object, not to a view function. And then it looks up the view for that content object. And even though that looks like a simple function call there, a view, it's actually dynamic, and I'll talk about that later. What does the developer need to do when they implement something with Morepath? They need to write still 6 lines of code, same as for the example with just using routing. It's just 2 separate declarations. So first you need to say, okay, I have a path to a particular address, and I do the query there, and then I define a view for the address, and the view delivers some HTML. So all interesting manipulations of how you can approach this. And this creative pattern I sort of call the dialectic. I mean, you want your cake to eat it and to have it at the same time, so you have a thesis and an antithesis, and you get a synthesis out of it. So I was like, I like these aspects of routing, and I can see it's really handy, especially when you have some ORM-backed objects, to use routing and not traversal, but I miss some of these aspects of traversal, so I wanted to do them both. And I first did this in another context when I was still working on the Grok web framework, which is based on Zope. So this delivers all of these features. So now let's talk about reg. So now we're all experts on view lookup now, so, and components and all that wonderful stuff, so we can go a bit faster now, right? So I lied about Zope before. So I had this sort of pretty thing where you had this interface. I want a view for this address in this request, and then you get some kind of object that you can then call. It actually looked like get multi-adapter and a tuple, and then a request, and then comma. I mean, it was just all a little bit more involved. I actually experimented. I first proposed a better API that would make this more regular in 2009, and then I experimented with implementing it in 2012, and sort of as a separate path, I worked with somebody for a little while to just experiment changing the insights of how this registry works, where all this magical interface lookups goes on. Because what this does is it really says, I want something that has the interface I view for an address and a request. And then I know that that interface lets me call it to actually get HTML. That's what iView promises. And of course, there's a registry behind that. So yeah, I experimented a lot, and it was all experiments. I wasn't actually thinking about really using this stuff. I was just had a few days at a sprint somewhere or whatever, somebody was visiting, and we just played around. We weren't serious about this stuff. Which is a kind of a nice creative pattern, because you're sort of a lot freer if you don't have to worry about all the backward compatibility and the legacy and all the, like, how this is going to work in the end and can we really do it. You're just playing for a few days, which I think is a really valuable way to create something. And you know what drove some of this is like, why is this so complicated? Let's just re-implement it from scratch. Some people say this is a bad idea. I sort of changed my mind on that. Let's just rewrite it from scratch. Why is this so complicated? And to learn sort of how this really works. That's one of the best ways to learn how it works. And in the end, it was sort of a generalization. It's all just a single call on interfaces to give you the right component, the view or the traversable or whatever it might be. So in the end, I decided, okay, all these experiments actually are kind of cool. I'm just going to throw them together and call it reg in the end and for registry. And I released this in 2013, and I built Morepath with it. And initially, it was just basically a rewrite of that SOAP component system, SOAP component architecture with a better API. It was a complete rewrite from scratch, but it was more or less sort of doing the same thing as before. And then, because I'd done a real rewrite, and I was very comfortable with the code, and I was able to make changes to it very easily, I started evolving reg. So why would you do this view lookup first and then you do this call second? Why can't you just do it in one step? Why can't I just call a function view that somehow magically calls my view that I need for that object? Because when I throw in an address, I want some HTML. Whatever I throw in a city or who knows, a foo, I might want a completely different view. So I want some kind of function that magically is loosely coupled there. So I started thinking about that. And you know, let's first sort of backtrack to 1967 to Simula, which introduced class-based dispatch. Class-based dispatch is what we're all familiar with. It's in Python. When you call a method, the first argument of your method will be the instance, and the class of that instance decides what method actually gets called in the end. So if you call bar on an instance of one thing, you might get a completely different method invocation than if you call it on an instance of another class. So what if functions were really like methods, right? What if you just, instead of having a method call there, what if you just can write a function call and just give it an argument? Why can't we do the second thing and still have the dispatch stuff work? So Python actually has an implementation of this hidden away in functools module somewhere, and I wrote my own in reg because I evolved reg to actually be dispatch-based sort of function, generic function implementation, multiple dispatch actually. So what does this more or less look like? If you use reg directly, you say, okay, I have a function here that's called show, and I want to show something, represent something with the print. And if I say, okay, this one is actually a magical function that when you call it, it might not get called if something more specific is available. So if you call it with an object that you haven't registered anything specific for, this will happen. It will just say cannot show. But if you, when we call it with an integer as the first argument, we want to print the integer. And if we call it with an address as the first argument, we want to print the street. And then you sort of make the right registration to make that happen. So you say, okay, for the show, the generic show function, I want to use show integer really, if the argument self is an integer. And I want to use show address really if the argument self is an address. And now when I call show, it will just call these two specific functions depending on the arguments, or it will call the original function if it doesn't know how to deal with the first argument. So that's single dispatch. And multiple dispatch is kind of a simple extension of this, which works on all arguments that way. So it's not just the first argument that's special, why you should self be special. All the arguments, you can actually dispatch based on them. And it happens in a certain order. So really, this whole view lookup business is really just a function call that does multiple dispatch. So I took reg, and because I'd totally rewritten it and I was very comfortable changing it, and I was the only user anyway, I just refactored the whole thing to make it a multiple dispatch library, and I wasn't afraid to break stuff. I could fix up Morepath fairly easily, so that was okay. And then it was a year later, in late 2014, and I mentioned already that Pyramid has this sort of view predicate system. So when you look up a view, it doesn't just depend on the class of the first argument, what actual view function gets executed. Like, you know, if the self argument is address, then I'm going to use this function. But it also can depend on other aspects of all the arguments. So it could be if the request object is a GET request, then I want to use this function. But if the request object is a POST request, then I want to use another function altogether. And it could be sort of any particular predicate you can issue over the arguments that can determine what function gets called in the end. So that's why Pyramid, sort of in its implementation, has to sort of layer this on top of the Zope component architecture to do this predicate-based lookup. And I thought, okay, what, examples of predicates first. So, the class of the object argument could be a predicate, the under class. It could be request method, like get, post, and put. Could be what's in the post body, could determine what function you want to call, or some other header. All of these could influence what view function gets called in the end. So I figured, okay, let's generalize this even more. We've single dispatch, multiple dispatch. Let's make it all predicate-based dispatch, because I need this in views anyway. Let's just make reg that way. And then object under class is just a special case that I can deal with within that system. And now, just this simple function call, which looks like a simple function call to the user, actually does this predicate-based dispatch. So it looks at information on the object, like the class, and information on the request, and then determines what view function to call, and therefore what HTML to deliver, or JSON, or whatever. And this gave me a lot more flexibility and control, and also gave me better caching for views, because suddenly I could cache sort of all the predicates. So if the next time you call the function with the same predicates, it can come from a cache, and that can be very fast. So, it's not as fast as normal Python function calls, but it's not super slow either. So yeah. Really, it's all, no really, right? It's yet another iteration. It's all function calls to do predicate-based dispatch. And this was an almost total rewrite of reg again. I mean, it sort of continued doing the same stuff, but it was a rewrite. And it was a rewrite of a system that's already a heavy refactoring of a previous rewrite of another system, right? So it evolves. Again, don't be afraid to break stuff, because you will get somewhere that's interesting. Of course, once I had done all that, and I'd gone all that route, and I made this big detour over components, I discovered that Philip Eby years ago already created this thing called peak rules that I heard about at the time, but I didn't understand. That is very similar to what reg actually does. So everything has already been defended before. So now let's talk about Dectate, sort of the third pillar of Morepath. I have no more time really, so I'm going to go really fast. So I lied about Zope again, right? So I keep lying about Zope. So I used a class decorator for Zope, but in 2001 that just couldn't work, because the function decorators only got added in 2005 and class decorators only in 2008. The future in 2001 looked very different than sort of it turned out. What you actually did to register stuff is use XML like this. So this was Zope configuration markup language. And yeah, you say, okay, I have this view, address view, you have to use specify a dotted name, and this view works for addresses. And ZCML has this nice feature, the Zope configuration engine, this nice feature. You can actually extend and override it. It's a general configuration system, so you can extend and override particular things using include statements. So you could say, okay, when I want to use a different view for addresses in my particular deployment of this application, that you'll be using some kind of command core, you can do that kind of stuff. You just write more XML, easy, right? So There's a long convoluted history involving Zope and Grok, another web framework I worked on based on Zope, and Martian, it's a library I spun off from Grok, and Venusian, which was a rewrite from scratch by somebody else, Chris McDonough, the author of Pyramid, of principles in Martian using decorators, and then I started using Venusian again, and I threw Venusian out again recently again, and now there's this library called Dectate, and I split it off from Morepath recently. And it's a meta framework for code configuration, so it lets you do this stuff with decorators, because decorators need to depend on each other, and there's all kinds of sort of fancy stuff going on under the hood. So let's give an example what you can do with Dectate. So here we have an application class. It took me a while before I realized there should be classes. So you have an application class, kind of like a Flask application object, and you say, okay, I want to have a view for an address there. So I just hook it up to the application class with my, and then I have a decorator, and then I just hook up my function there. So once you have this is my core thing that handles, I don't know, customer relationship management or something wonderful, right? I've written this big sort of core framework, and now my client says, your CRM is perfect, but I want to deploy it, and I want just this view different, right? So what do you do then? Well, you can mess around with all kind of ad hoc configuration frameworks, but this is a general configuration framework. Or I want to add a new view, so let's look at adding it for a view. So let's say you want to use everything in app, so you just subclass it like you do in Python, and then you say, okay, I add a new view here that works for cities, and now suddenly my subclass of the application, but not the original application, is capable of displaying cities as well. That's kind of nice. So you just you can extend any directive in Morepath, use any directive in Morepath in your extension and just write just more code. And the original code is unchanged, but you've extended it. And you can also do overrides. If I say in my sub-app, I actually want to use a view for address again, like I had in my initial application there, I have a view for addresses. Then I can just plug in another function. And now in the sub-application, but not in the original application, this new view function is used. And Dectate only takes one minor meta class sort of to accomplish this whole class business. So yeah, it's all just subclassing. Again, I changed it around quite a lot. I had application objects, now I have application classes, but I needed that detour. I was using Venusian, now I'm not, but I needed that detour to learn it. And one of sort of the other things that I sort of patterns behind creativity is that if you have some code that does something, it's often a good idea to take it and split it off into a library that's really focused on that thing only and nothing else. And then it's easier to test and easier to refactor and easier to document as well, because this whole Dectate business has been part of Morepath since the beginning, more or less. Never was documented, but now that I split it off, I could refactor it without worrying too much about the past. And I could write documentation for it as well. So splitting it off into a library often helps you focus sort of a particular piece of your application. Suddenly you generalize and you document and you can test a lot better. So now that I've shown you all of this, you can actually understand Morepath's implementation. So there's this module core inside of Morepath. And here, this is how it does a thing where your model is address, and it hooks it up to that. So you say, OK, the class of the object is actually determines whether this view matches or not. So this is just part of the Morepath implementation. This says, OK, if you have this lets you hook up views to addresses or to cities or whatever. And it uses a class index, so it's aware of subclassing. So this works for addresses, but also subclasses of addresses. And then if it doesn't match any class, then I want a 404 error. So I just raise HTTP not found if it doesn't match. That's sort of the fallback to the predicate. And then here, there's another one for the request method, get and put and post and all those things. It's just the method argument of the request object. And if it doesn't match, then there should be a method not allowed error, a 405 error. So this is just really just taken from the Morepath core, literally. This is the implementation of that generic dispatch business. And since it's based on Dectate, this means that you can actually extend this. You can add your own predicates. You want to handle the accept header. It's not a Morepath. you can write your own predicate that handles this. So you can even override particular predicates if you want them to behave differently, only for your applications. Other applications in the same runtime are not affected by this because they have their own configuration. Thank you. Any questions?